Hey guys, we are here for video 5 of the upper extremity unit. I will do my best to keep this video short. I also want to show you guys some videos of an endoscopic release of carpal tunnel syndrome. We're going to see a video of a Colles fracture. We're going to look at not see videos of Boxer's fracture. There's one of these muscles we're going to look at today, one of these 4 muscles. Some of you will not actually have, and some of you won't have them on just one arm, but you'll have it on the other arm. And so we'll talk about that. That's some of the interesting pathology as we'll go through. So overview, guys, of these muscles. This is the last 4 muscles of the upper extremity. I'm choosing 16 of the upper extremity after Christmas break. We'll do 16 of the lower extremity. We're talking about the palmaris longus right here. We're talking about the extensor carpi radialis longus, the adductor pollicis, and the opponens digiti minimi. Those 4 are the 4 we're looking at today. So quick review. On your hand, I would pause the video and review the 8 carpal bones. I think this helps because we'll talk about these 8 today. Talking about the scaphoid, so long to pinky. Here comes the thumb. So scaphoid, lunate, triquetrum, pisiform, hamate, capitate, trapezoid, trapezium. So review that on your own hand. Just quick review. So some bones, bony landmarks. I'll review this again briefly in the beginning of class next time. The palmaris longus, guys, originates on the medial epicondyle, and the palmaris aponeurosis is the insertion point. So medial epicondyle we've looked at before. This is the 2 epicondyles on your humerus right here. So it originates on the medial epicondyle. And this palmar aponeurosis is this fanning out of this tendon kind of over the carpals. So it goes all the way down from your medial epicondyle all the way down to, and kind of fans out. Here we call that an aponeurosis. Basically like a tendon, but it can also just attach straight to a muscle, which is what the palmaris longus does. It doesn't even attach to a bone, just attaches through a tendon to other muscles. So that's unique. Extensor carpi radialis longus, super long name. This is the one long named, I would argue the longest named muscle I'll have you know this year. It originates, guys, in the lateral supracondylar ridge, and it inserts on the second metacarpal. So again, on your hand, your metacarpals are your palm bones, so that inserts down here on the second metacarpal. It originates on this lateral supracondylar ridge. Long title, I bet you can probably guess where it is. So where on your elbow would this thing be? It's not medially. It's above this lateral epicondyle, above it on this lateral supracondylar ridge. So I'll show you guys a picture of that real quick. So right here is the medial supracondylar ridge, but this extensor muscle originates on the lateral supracondylar ridge, so above the lateral epicondyle. So bam, there's that. Adductor pollicis has several origins insertions. That I think you can get from what we've talked about in the past. Again, review the carpal bone section, the hand section in your muscle packet. I've included those bones for your review. Also, the opponens digiti minimi originate on the hook of the hamate and insert on the 5th metacarpal. And those we've talked about before. Come and see me if those are still a mystery to you. Joint review. There's some crazy joints in this section that we'll be talking about. So just quick review of this diagram right here. Again, if you can't see this, if this is on your cell phone, I've also included my slides in the Google Classroom post. So go there to maybe see this slide. I'm going from the humeral ulnar joint down through the proximal radioulnar joint, through the distal radioulnar joint, to the radiocarpal joint, to the carpometacarpal joints, or the CMC, all the way to your metacarpophalangeal joints here, to your interphalangeal joints at the end. There's 2 interphalangeal joints on most of your fingers. So those are the joints. Those are what we're going to be talking about. What these 4 joints move are at those joints I just reviewed. Okay, so the first muscle, guys, is the palmaris longus. This is a cool one. Again, he originates on the medial epicondyle, inserts down on this palmar aponeurosis down here, and he primarily does radiocarpal flexion since he crosses that joint. And again, we'll build this guy tomorrow, and we're gonna keep the motion simple. What's unique about this muscle is actually NCBI, National Center for Biotechnology Information. If you ever want to Google search something in science, type in NCBI or probably more generally NIH, National Institutes of Health. And it's like an incredibly reliable Google search, much more reliable than Wikipedia. So they did a study on 300 Caucasians, 150 males, 150 females. They found that that 16% of people are missing their palmaris longus tendon. If you guys flex your wrist, it's this big guy that sticks out. You guys can see this. It's this big guy that sticks out in the middle. 16% of people are missing it in one arm, and 9% are missing it in both arms. So a quarter of the population are missing this muscle, this palmaris longus muscle, in at least one of their arms, which is weird. So there is genetic diversity there. There's some evolution going on there too, because I'm sure that's changing over time. Second muscle, guys, is the extensor carpi radialis longus. Again, this guy originates on the lateral supracondylar ridge above that lateral epicondyle. He goes down around to the backside. If he's going to be extending my radiocarpal joints, he needs to be going down the backside. He inserts down onto the second metacarpal bone, so down here, and he extends my radiocarpal joint. And since he's going down the side, he also abducts it. So again, if this is my wrist, he's going to do a little bit of abduction and extension. Both of those. This diagram right here shows the origin, so is the insertion. If you guys can see the red origin and the blue insertion. This is probably the clearest picture, this green picture of the whole muscle. So it's a beautiful shot of it. Why do I pick this muscle? Of all of the muscles I could have picked that might have been cooler, I picked this because this is an example of how muscles are named. So this is something I want you to take to college with you. Is in the name of a lot of these muscles, you can tell what they do, where they are, where they're located, and how long or short they are. So the extensor, if you can't read this box, again, I would open up my slides from Classroom. Extensor shows its function, so opposed to flexion, it extends. Carpi is the joint that it works on, so the radiocarpal joint, the wrist joint, is the joint where the motion is produced, as opposed to the digits, the digital muscles attached more distally. The radialis section is it's going to be running along the radial side of my forearm, not the ulnar side of my forearm. And this longus, as opposed to brevis, this is the longer of the extensor carpi muscles. There's also brevises that I'm not choosing to build. But in this one muscle name, you actually have most of its locations and functions wrapped up in the name. So I think that's pretty cool. Okay, muscle 15 is the adductor pollicis. This is one of the coolest shaped muscles, honestly, of the hand. He is a big triangular shaped muscle, originates on this third metacarpal right here. He also has a second origin point of the capitate, so this carpal bone right below the middle finger, and the second metacarpal bone. So if you guys can see this diagram, let me make this on top. You guys will see the origin points here, and it actually goes on the second metacarpal as well, and it inserts over to this first proximal phalange right here in green. So that is the adductor pollicis. We'll build this in class. Pretty fast muscle to build because it's short, but your mannequins don't have great carpal bones, so we might have to draw that in during class time. What I did in my very first year of teaching anatomy is actually had my students build 8 muscles, the 8 muscles of the thumb. There's 8 muscles that go to your thumb. And thumb, every time you see a muscle that goes to the thumb, it's called pollex. See, the adductor pollicis goes to your pollex, or your thumb. So that pollicis denotes the biggest part of the biggest phalange of your hand. The hallux is your big toe, so hallucis will be all the muscles going to the big toe. We'll find that out later. But I find it weird that this big muscly part, the reason why you have so much muscle mass, so much this big jutting thing out in your palm, is there are so many muscles there on the front and the back. There's 8 of them that go to your thumb that produce all of the motions of the thumb. So let me pull out the motions of the thumb. This I would write down. There are many motions of the thumb that it does. Your thumb coming straight across is flexion. Extending back out, that's extension. There's also abduction. As I'm going towards the camera, you're abducting towards the camera, adding it back to my palm here, adduction. And then there's opposition, which is what we usually think of when there's the pinky and the thumb. Opposable thumb means that the thumb is able to basically touch the pinky and squeeze things that way diagonally. So again, flexion, extension, abduction, adduction, and then kind of diagonally opposition are the motions of the thumb. This particular muscle, guys, does, I would say, 3 functions. I would add one to your muscle key. The first thing it does is it produces opposition of your carpo-metacarpal joint. So that helps oppose that section. So that's opposition produced there, the carpo-metacarpal. Since it's inserted, guys, on the base of this first proximal phalange, it also produces flexion of that first metacarpophalangeal joint, that MCP joint. And yes, it does adduction too. I think it's a little bit unclear whether it does opposition or adduction. But again, adduction is bringing the finger, the thumb back, adduction, which is a lot like opposition. So it really does kind of a crossover over those two. So opposition, adduction. It's named the adductor pollicis, so it also adducts. Okay, last muscle, guys, is the opponent's digiti minimi. We looked at the big phalange, the pollicis. So now we're going to look at the smallest one, the digiti minimi. This applies to your pinky phalange and your pinky toe. So pinky finger, pinky toe. Guys, it originates on the hook of the hamate. So again, so long to pinky here. So the hook of this hamate is what my cursor's pointed on right now. And it inserts onto this 5th metacarpal, this ulnar border, this, in this case, the medial border of this 5th metacarpal. And what it does, at the pinky, it also produces this kind of opposition of that joint. So those two muscles together produce that amazing ability for your thumb to touch your pinky, which not many species have. And yes, this is also used by, is it Dr. Evil? I haven't actually seen this movie in a long time, to take over the world. How this applies to an injury, really brief injury. The boxer's fracture is a really common one. Isn't it just suffered by boxers? This is oftentimes suffered by stupid people who are hitting, and by stupid people I mean maybe over-emotional people who are punching walls when they're angry. This is an injury, guys, to the 5th metacarpal or the 5th metacarpophalangeal joint. So oftentimes this is a fracture. If you guys see this picture right here, this is a pretty clean break of this 5th metacarpal. It also just might be a partial or a full sprain of the ligament surrounding your 5th metacarpophalangeal joint also. So that can also be a boxer's fracture. Yeah, I know that's not a fracture if it's not actually fracturing a bone, but sometimes those are linked together. So bam, that's an injury kind of linked in that area to that small finger. So we're done with muscles. We talked about one injury. This is my family. This is my mom. In the background, my mom is a widow here in town. My dad passed away about 6 or 7 years ago. My brother's out in Ohio, so we spend a lot of time with my mom. She loves my 3 kids, Luke, Enika, and Florence. This was my daughter Enika's 4th birthday. And yes, Florence was engrossed in her presence. It always feels like you're kind of partially receiving your older sibling's presence. Okay, the joint of the day, guys, is the radiocarpal joints. We've talked about the SC, the AC, the glenohumeral, and the humeral ulnar joint kind of in detail. And the last one we'll talk about is the radiocarpal joint. So it is a condyloid joint. It is one that produces that kind of U-shaped motion, and it does flexion extension too. But it is a synovial joint since it moves so much. It is the articulation, guys, between the radius, kind of on your thumb side. Radius is rad. So between the radius on your thumb side and your carpal bones. The ulna doesn't really make any articulation or touching with your carpal bones in that joint. It's stabilized by a couple of ligaments, by the ulnar collateral ligament, radial collateral ligament, and palmar radiocarpal ligament. And I bet you can kind of guess where these are. So my radiocarpal ligament is going to be on this side, on the radial side, so radial collateral. The ulnar collateral is going to be on my pinky side, so ulnar collateral ligament. And this palmar radiocarpal ligament are the ligaments that is in red here that kind of traverse the gap between your radius and your carpal bones. So all this red is palmar radiocarpal. This green is ulnar. This yellow is radial. The motions, guys, produced at this joint are, I mentioned it earlier, flexion, extension. So I am flexing my wrist right now. I'm extending my wrist. And I also, standing in this position, I'm going to abduct and adduct, or radially deviate and ulnar deviate. So ulnar deviation, radial deviation is the same as adduction and abduction of that joint. So those are synonyms. Don't you love synonyms? Okay, guys, some pathology that we can talk about. Foosh, the MOI, foosh. MOI in athletic training or physical therapy is mode of injury. So the mode of injury of a lot of different injuries, there's different modes of injury. The ones we're going to look at right now are caused by foosh, by people falling on outstretched hands. So falling on outstretched hands. So the MOI is foosh for this Colles fracture. If you guys see this X-ray right here, let me make this bigger and in front. You guys see what has happened to their forearm bones in this case. You guys see this fracture here. This looks like not actually the thumb side. This actually looks like the ulnar side. There's an ulnar fracture. So a Colles fracture, guys, is a fracture of either the radius or the ulna, the distal radius or distal ulna. You guys can see these pins set in this radius, actually screwed in. So this metal plate that's screwed in. This is a Colles fracture. So a distal fracture of the radius is the most common, but it can also include the ulna. And the MOI is foosh. Another injury that results from falling on outstretched hands is a scaphoid fracture. This is probably the most common foosh injury. As you fall out on your hands, injuring your scaphoid, again, these carpal bones start on this thumb side on the bottom. So your scaphoid bone is here. The other way to know this is on the back side. If you hyperadduct your thumb, here you can actually tell there's this kind of valley right here, and they call this the snuff box. They actually used to inhale snuff, which is like a tobacco-like substance. I honestly don't know that much about snuff. But this is called the snuff box because they would put it in there and snuff it up through their nose. That snuff box, if you put your finger on the top of it, that's actually the back side, the dorsal side of your scaphoid bone. So that scaphoid fracture is super common as you fall on outstretched hands, injuring that scaphoid bone. Hard to heal because there's not a lot of blood flow. So this sound familiar? Short bone, avascular, hard to heal, takes a lot of force as you fall out on your hand. That's a lot like Yao Ming's tarsal navicular bone, avascular, takes a lot of force, the keystone bone. So there's a lot of parallels here. So while we're on the subject of foosh, I thought I would show you guys a clip. Again, you can type this in, wrist fracture, drER.tv. Sounds a little suspect to me, but this video I think was good to show some fracture types. Sounds like you guys like these videos.
The real problem. This is a video of a wrist fracture. You can see that bone nice and intact. That's the radius. You can see that bone is pushed on the side. This is more like a little oblique view of the same X-ray. You can see that distal fragment on the radius is impacted on the bone, and it's really bad fracture. This patient presented to the ER obviously because of a lot of pain in the wrist. She had fallen on her outstretched hand. We call the acronym is FOOSH, or FOOSH.
So let's just go to the real problem. This is a video of a wrist fracture. You can see that ulna is nice and intact. That's the radius.
So we're saying ulnar styloid. The styloid processes are the bumps you can feel on the outside of your wrist, are the radial styloid and the ulnar styloid. And so those are really common injury sites.
And there's an open operation.
It's really bad fracture. This patient presented to the ER obviously because of a lot of pain in the wrist. She had fallen on her outstretched hand. We call the acronym is F. The ulnar seems intact except for that right there. That's a little piece of bone, or the ulnar styloid, right? This is supposed to go right here, so it's always displaced that way. So let's go ahead and look at the other x-ray here. Oops, I didn't want to see that one yet. This is after the reduction. You can see how beautifully reduced that wrist is.
So the reduction would be a resetting of the bone. So they've reduced this radius kind of back to normal. So a reduction is the procedure that they would do.
We gave this patient sedation through the IV. She was actually still awake, still breathing on her own, conscious. looking around, but she was fighting us. It was hurting, but when we were done, she didn't remember any of it, so it worked great. We were able to reduce the risk. Now, I wasn't too optimistic how much good alignment I was gonna get because I had to basically grab the bone where it was broken out of place and pull on it, and I wasn't feeling it going back in place. So I ended up doing a hyper flexion like this and moving away from the fracture until I felt some cracking of the bone and I got it into place. Then I put a splint that went on the volar side and on the dorsal side, wrapped it around, took another picture, and this is what we have. You can see the styloid process here used to be over here, so that's been reduced as well. You can see the alignment.
So you realize how on the fly a lot of these procedures are. He was just kind of experimenting with how to get that bone back in there, and he wasn't able to do it for a while. So I find that interesting. Okay, so moving on, guys. The last pathology we're going to talk about is the carpal tunnel. Carpal tunnel, guys, is an actual tunnel above these 4 carpal bones. There's this actual tunnel that a whole bunch of muscle tendons and a nerve, one particular nerve, runs through. And what you find is people who are extended throughout the day, who are typing on their computer like this, have compression of the nerve that runs. It's kind of superficially in this tunnel. So that's carpal tunnel syndrome, CTS. So quick review. This is actually the transverse carpal ligament. Transverse carpal ligament is that ligament that runs on top of this picture we just saw. This ligament up here is the transverse carpal ligament. It runs across the palm in a transverse way. So transverse carpal ligament right above the carpal bones. So can you guys guess which carpal bones that transverse carpal ligament attaches to? And there's 4 of them. So again, this carpal ligament, guys, runs across the side. So it runs from here across the way, kind of on top, and that's what creates this top form of the bridge. And so what you find is the four carpal bones that are involved have to be the ones that are lateral. So it's the trapezium and the scaphoid on the thumb side, and it's the hamate and the pisiform on the pinky side. So pisiform, hamate, there's this big tall hook, and on the thumb side it's the trapezium and scaphoid, and that's where those attach to. And there are actually 10 muscle tendons in the median nerve that run underneath this transverse carpal ligament. So underneath this section you find that carpal tunnel, and you find a compression of the median nerve is causing all of that nerve damage, that discomfort, that pain that people suffer. So this is a pretty cool picture of it. If you guys see these 4 carpal bones, and right above that you have all this huge flexor group and the median nerve right on top. That's what's usually compressed by that transverse carpal ligament. How does this relate back to what we talked about in the last video about tennis elbow and golfer's elbow? If you guys remember which muscles originate on this medial epicondyle and what function this muscle group produces versus one on the lateral epicondyle and what function this produces. This section here on the medial epicondyle are the flexors, and that's basically the majority of these 10 muscle tendons that run through the carpal tunnel are the flexors. And so when you have that flexor group extended a lot, you have kind of a muscle strain there in that flexor group, but you have that median nerve compression. So it's largely due to all of those wrist flexors running through the carpal tunnel that increase that compression. So interventions, how do you treat carpal tunnel syndrome? So you're a therapist, you're a professional, someone comes into you with a lot of pain in their wrist. They didn't fall on it, there's no foosh, that's not the mode of injury. But they do work in an office all day, they are on their computer a lot, and it's just this discomfort that's slowly built up over time. Stretching is probably the first least invasive intervention. So invasive would be the most you have to dig into somebody is the most invasive. So stretching is a great place to start. So stretching, you can have them stretch out their flexors. So I'm going to stretch out my right hand, stretch out the flexors in that group to try and decrease some of this inflammation in the carpal tunnel. You can also do a prayer stretch where it's almost doing the same thing, stretching those flexors. And you can also stretch out the pronators. So my pronator teres and my pronator quadratus down here we didn't build. Both of those contract and get shorter here. So to stretch them out, I'm going to pull my wrist the other way, the other direction, and stretch out my pronators a little bit. And that's one of the stretches you can do, stretch out the pronators, because the pronator teres runs that way. Or you can have them do the Spider-Man, and I want you guys to do this with me. If you guys can see this picture, the Spider-Man stretch is a great way to get all of that, all of the motions together. And I encourage you, if you're somewhere, do this right now. It feels pretty good. And actually having a patient do this Spider-Man activity, this Spider-Man stretch over and over and over and over again, I can actually feel quite a bit of stretch in my flexor muscles and a little bit of stretch in those pronators too. So it's almost doing both of those at the same time. So that's pretty fun. Again, I encourage you guys to try that out a couple times. It's fun. It's a fun break. Second least invasive way of treating CTS is using NSAIDs, or non-steroidal anti-inflammatory drugs. One way to remember what counts: Tylenol, Advil, ibuprofen come to mind. The only ones that are non-steroidal anti-inflammatory drugs are what a lot of students remembered were the A and the I, were aspirin and ibuprofen. These are anti-inflammatory drugs, not just pain meds, but ones that decrease inflammation. Aspirin, ibuprofen do a great job at decreasing inflammation, not just pain. So this is maybe one of the first things to prescribe are NSAIDs. And then the third type, guys, is surgery. So let's say this person, these non-invasive methods aren't working. So eventually you conclude that surgery is the next best option. You can have an open surgery or an endoscopic surgery, and the endoscopic is the least invasive, because if you guys can see these two pictures, the open surgery, you make a huge incision and you cut this transverse carpal ligament. The endoscopic, you just make, at the very most, 2 holes, but most commonly it's just 1 hole. So I'll show you guys a video of this.
This is graphic medical footage. This is live endoscopic carpal tunnel surgery performed by Dr. Stephen Helgamo at Southwest Florida Hand Specialist. First, the endoscopic carpal tunnel incision is marked on the skin. It measures about a 1/4 inch in length. Next, we're depicting where the transverse carpal ligament lies and the traditional open carpal tunnel surgery incision if this were to be used. An upper arm tourniquet has been placed to allow a bloodless field. The S-mark bandage is then used to exsanguinate or squeeze the blood out of the hand, and the tourniquet is inflated to allow temporary restriction of circulation.
So it pushes all the blood out.
The small 1/4 inch incision is made, taking care to only cut the skin, none of the underlying structures. The patient is under sedation and is given local anesthesia to prevent any discomfort during the procedure. Specialized retractors are used to provide access to the palmar fascia and distal forearm fascia. A small window in this is made to allow access to the carpal canal. The distal forearm fascia is then released, and specialized instrumentation is used to separate any contents from underneath the transverse carpal ligament to allow access. This is a dilator instrument which is used to provide a pathway for the endoscopic carpal tunnel instrumentation, which is shown here. It is then placed within the carpal canal.
So this is pretty cool. This is where it gets cool.
As you can see on the video monitor, the transverse carpal ligament is identified clearly with fibers going across the screen. The blade is then elevated.
So it's cutting.
The instrumentation withdrawn.
So it's cutting the deeper underneath the transverse ligament, cutting it.
As you can see, providing adequate release of the carpal tunnel. That pink structure above is muscle. The skin is then
And that's it.
with
They just cut the transverse ligament.
medical super glue. And again, it measures about 5 millimeters.
Medical super glue. That's the expression of the day. So that's less invasive than open surgery, but far more invasive than stretching. So that's not the first option. So I would pause the video, guys. quiz yourself, what's the ligament name that goes above the carpal tunnel? How many tendons, muscle tendons run underneath? Are those the flexors or extensors of the radiocarpal joint? Which nerve lies superficially above those tendons? What's the least invasive interventions? What's the most invasive interventions? So I'll review that real quick. And then the last thing, guys, we're basically done. Last thing is the nerves. We'll go over arteries, veins in class because that's easier to show in class. But what you see on this very first packet I gave to you guys of the upper extremity had this labeling sheet on it, where you have your brachial plexus up here, and then that brachial plexus eventually gets down to three main nerves. This inside portion along the ulnar border is this ulnar nerve. Usually what we think of as the funny bone is actually this section right here of the ulnar nerve running underneath your medial epicondyle. That's actually what you feel, that kind of funny tingling sensation. Your median nerve extends down through this middle part, and then your radial nerve actually, and it should say radial, it shouldn't say radian, it should say radial, goes back behind the arm, this dotted section, behind the humerus, and around to this lateral portion along the radius. That's the radial nerve. And you have problems with each one of them produces a different kind of issue. So here's three issues. The hand of benediction, if you guys see this top picture, is like this. This is one problem some people have. They can't get their hand out of this position. You also have claw hand, where it's like all the fingers are back, extending backwards like this. And you have a wrist drop. And a problem in each of the nerves causes each of these. And this relates to the flexor extensor group idea again. So let me explain this real quick and we'll be done. So running along the ulnar nerve, guys, this ulnar nerve runs along this medial section. So again, thinking ahead of yourself, is this my flexor group or my extensor group that's affected by my ulnar nerve on this medial section of my arm? If you're thinking flexors, if you guess flexors, that's great. So if you have a problem with your ulnar nerve is pinched or damaged or just dysfunctional, your flexors won't really work, and you need your flexors to be able to control this motion. So if you don't have your flexors functional, then your hand goes back into this motion, which produces claw hand. So claw hand results from ulnar nerve issues because you need these flexors in the front to be able to control your hand into this neutral position. So you cut those flexors, you disable the flexors, and you go back up into claw hand. This median nerve, guys, is almost like a halfway. These median nerve controls some of the flexors, but not all of them. And so what you find is you have almost like claw hand in a couple fingers, and that's what we call the hand of benediction, like this. Just these first two fingers have this issue and go back up. So hand of benediction, almost like a priest saying a prayer. Benediction means a blessing from God, so it's someone who's giving a blessing to the people. And then the last one is the radial nerve on the outside. It goes to this extensor group extending from this lateral epicondyle. And when your extensors don't work, your extensors can't keep your wrist up, so you have this wrist drop. So radial nerve issue, median nerve issue, and ulnar nerve issue, claw hand. Hand of benediction, claw hand, wrist drop. So I'll review that, and I am done. See you guys.